progress. I just hope that's gonna very grateful that they're gonna like our LED with this anime edit channel. Okay, next is why it has been anime because uh, for this topic we can do with an enjoyable with some searching features and then we can upload it, some content to be an interesting. And next is music. The music that we found on TikTok and it sounds suit very well for our edits. That's why we chose this music as our project video. Oh, okay, next.
For the Arduino architecture, we use the code example from Professor. We didn't change anything, but I just so that is for the architecture. So, for the code is very simple. We just in the Professor code and we adjust the delay and position of the light that you link link to match the rhythm of the song. Yes.
Thank you. Oh, that's all. Welcome.
Please show your code.
Go back, go back.
Uh, your your code is look like a LED, fire LED on and off, right? In the line, line 39,
39.
39 to 44.
Yes.
Yes. And why you set the value is 700, 170?
I calculate the millisecond from the song. It's like
Uh,
170 and 50.
you mean the delay time is related about the song?
Yes.
Uh, can you play the, the video again on the TikTok? Okay, very good ถ่ายรูปหน่อยครับเปิดสไลด์หน้าแรกเลย Please open the first slide and take a picture please Okay 1 2 3 thank you The next presenter is the group name is ชื่ออะไรนะ Daniel Daniel
LED light lamps, our computer architecture project presented by our member speakers. Introduction to our project. Welcome to the Arduino LED control presentation today. We have learned how to control LEDs using Arduinos. We'll cover the setup, code explanations, and practical demonstrations. Here's the setup. We have Arduino connected with LEDs and switches. LEDs are connected to pins 8 to 12, and switches are connected to pin 6 to 7. We'll control the LEDs using binary input from the functions LED on off. A breakdown of pin assignment for LEDs and switches as defined in the codes. LED 1 is connected to pin 8, LED 2 is connected to pin 9, LED 3 is connected to pin 10, LED 4 is connected to pin 11, LED 5 is connected to pin 12, SWO switch 1 is connected to pin 6, and SWO2 is connected to pin 7. And here's the code explanation.
As for the code explanation, we first define LED 1, 2, 3, 4, 5, and switch 1 and 2. This line gives a name for the variable of each wire that is connected to the Arduino. The number that is after the variable is the pole that the wire is connected to in the Arduino. Define on and off. This line makes two variables that decide whether the LED turn on and off or off, respectively. Chart string message 10. This makes an array string that can hold up to 10 characters. The function setup. This function declares LED 1, 2, 3, 4, 5, and switch 1 and 2 as an output, meaning that not only can the function be able to turn the LED on and off, it can also take the input from the switch 1 and 2. As for the serial number pin 9600, set the data baud rate at 9600 bits per second. For the LED on and off function, this makes a function that, like the name suggests, turn on the LED, turn on and off LED. Inside the function, there is a parenthesis indicating an array string called RRLE, which can contain up to a character and so declare a variable called delay time that is defined as an integer. Inside the function string, print out the desired text that is inside the parenthesis. This works almost exactly like print in Python. Serial.write string message. This takes the content of the variable string message from the Arduino to computers. And for the if statement, it takes an array name ARLED that will be contained with array number example as 1000, 00011, etc. and check whether the index is called is equal to 1 or 0. If it's equal to 1, it will turn on the LED. The LED that turned on depends on the variable that it was given. If it's 0, then it will turn the LED off. As for the delay time, take the variable delay time that will be defined in the Arduino code. The number inside represents milliseconds. For the function loop, this function will call over the function LED on off and define the variable inside the parenthesis, which will loop over and over again. The first variable in the parenthesis is a binary number. Second variable is delay time that is used for delay time.
Now, as for the delay time and all the patterns, we actually follow this the Pinot patterns. Like you can search on Google like the song and then Pinot pattern, and then you
Yes, and lastly, our kids video TikToks. This clip only got 50 likes so far. You guys can go check it out. And the concepts are not pretty complicated. We just add songs and clips of the live bands. I can't open the clips. Yeah, thank you.
Could you play a clip? Okay, this is the LED turn on, turn off look like the piano key or the rhythm in the songs. And could you show the like number on TikTok? เท่าไหร่ครับห้าเมื่อกี้เพื่อนได้30 บาท The last cookies is a 30 นะ192 oh, like for view is a 192. Yes, yes. Okay. And this is moving back to show the code about the delay times. Uh-huh. Please tell me the technique for determines the delay time value. That is a match for the music. I see the delay time is a 100 and 200. Could you tell me about the setting the delay time matching to the music rhythms?
What we actually did is like trial and error, and we just keep on trying different numbers until we get the right rhythm. It's actually like really like tedious and process, but like we are just like estimating it, not really like the exact number, the exact millisecond, just to make it as close as possible.
Okay. And another line of code, you modify only LED on and off, right?
Yes.
โอเคถ่ายรูปก่อนครับพี่ we will take the pictures for the group ครับมาถ่ายรูปมาให้เป็นหลักฐานยืนเข้าไปที่หน่อยครับ close together โอเค one two three thank you the next presenter is Artipong
Good afternoon, everybody. Today we're going to present about LED dancing. The objective of LED dancing is understanding microcontroller architecture, involve comprehending in design, component functionality, ISA, memory, organization, interrupt handling, coding scheme management, and system architecture.
So the gadgets for our project consists of Arduino board, LED resistors, breadboard, jumper wires, and lastly a USB cable for connecting the board to the PC for coding or programming.
How to create LED singer. So the first step is build, as you can see as previous slide. Second step is set up the circuit, place the Arduino board on the breadboard, connect the number link of the LED to one of the digital output pins. Use the current limiting resistor to connect the
into the ground beyond the arena. And the third step is the wire code. I don't know any how to do that. Right. Right. The normal is to control the LED and output. And the last step is test the setting. Once the code is successfully, the LED should start shining with the program access. This is our code. So it just same like yours, but we change a little bit of the delay so it match our music. This is our result. Sorry.
It has the LED on your
Again, please.
again this here. Oh, okay. You, thank you. You keep it is a very short, but the code is very long. Why?
Because in the first time we have a problem with copyright music, so we have to make the clip shorter than USB.
Could you play a long version? We have a video clip, another from outside, not the in the TikToks in the long version. No,
And a long version.
we have a very short version.
Short version in TikTok.
Moving back to the code again, please. In the code, you modify only a LED on off, right?
Yeah.
This is a 50 milliseconds, very short. But the code you can grouping the code example in line 67 to the 71. This is the same meaning. This is a 11150. You can grouping only one code. Only one line of the code is set about 300 milliseconds to optimize your code. Because your code is very long, but the code used is the same in the 4 line, 5 line in the group. This is a substitution. And for the pattern, this is the move left or right to left, right? And LED on and off. You have okay, now we will take a picture. Please open the first slide. Now we take a picture. In sports student group 1, 2, 3. Thank you. The next presenter, Cherry, Red Cherry. turn on.
So good afternoon, Anya and the classmates. So welcome to our group. So today we are going to discuss about how we develop our LED dancing project. So the table of contents for our project is, okay, so we are going to discuss about the objective of this project, and then we will explain about the components we are going to use in this project, and then how we set up the circuit, and we're gonna explain the code and what we observed during this experimental, and then we will conclude it. Okay, so the main objective of our program is to know how to interface the LED and with an audio using a breadboard to control the LED. So during this experiment, we learned the basic knowledge of electronics and the microcontroller programming, and then the concept of digital output control. Okay, so before we start, let me explain a little bit about Arduino. So in here, in Arduino, so then from the top, there is a yellow line. There is a yellow one, it's called analog reference pin, and after that there is a light green pin, it's called digital ground, and after that you can see there is green color dots from number 2 to 13, it is called digital pins. And after that, there are 2 dark green, and it is serial input and output. And after that, below that, there is the blue color, it is reset button, and beside it, there is light blue, it is analog pin. Okay, so let's go to the down. Okay, in here, there is powertrain, and in the middle there are ground pins, and after that, for the pin 1, it is for the power, external power and USB power, and the yellow one you can see is USB, and we use USB to communicate between the board and the computer. Okay, so in this project we use Arduino, but the full time. It's really useful and easy to use for the technical way for the students, and we also use breadboard and 5 LEDs and like 6 jumper wires and 5 resistors. So in here we use 200 ohm resistors so that it can produce lighter. So the way to build the circuit is the following. First, we use a jumper wire to connect the ground pin to the Arduino to the negative rail on the breadboard. This allows the LED to use the ground pin on the Arduino. Then we inserted the resistors onto the breadboard space. We space out the resistors with one leg connected to the positive rail, and after that we insert the LED, connecting the negative leg of the LED to the horizontal rail, which the resistor is connected to. After that, we connect the positive leg to an adjacent rail. We're going to use the output ports 8, 9, 10, 11, and 12 for the output signal connected to the positive legs of the LED. So this is our code. The program first creates 5 different variables named LED 1 to LED 5, and this allows us to change the output pins without us having to rewrite the entire program. The code of the setup class of the program tells the Arduino that pins 8, 9, 10, 11, and 12 will be the outputs, and the variable LED 1 to 5 respectively. Then afterwards, the loop portion of the program is where the actual instruction of whether which light should turn on and which light should turn off is. We set up the function turns on the LEDs and the line with a 50 millisecond delay between each of them to keep the red on the LED turning on and off. So our program, as we can see, has a bunch of zeros and ones and numbers after the zeros and ones. The 0 means that the light is off, and the 1 means that the light is on. The numbers at the back is the delay in milliseconds of whether the LED is off or on.
The observation in this project, the concentration and magnetic turns on and off of the LED connected to the pin 8, 9, 10, 11, and 12 of the Arduino. Each LED will turn on and off in a specific pattern controlled by the program. The use of variables for the LED pins allow for easy modification of the pin numbers without changing the entire program. The delay between each LED turning on and off can be adjusted to create different visual effects. Overall, the program demonstrates basic LED control using an Arduino and can be starting point for the complex LED project.
And for the conclusion, conclusion, this project demonstrates a simple and effective way to control multiple LEDs using an Arduino microcontroller. By connecting the LEDs to the Arduino via breadboard and writing the program in C language, we were able to create a visually appealing set of LED light patterns. This project is a great introduction to basic electronic and programming concepts, offering a hands-on learning experience for beginners with experimentation and customization. The possibility for creating unique LED display are endless. Okay, so 232 right, 232 likes and in particular we got 95. Thank you for listening.
And please play the video again. And show your code. Okay. And please show the code. And the code, can you show the code at the line before the end of the music? Do you have code only 64 right? Yes. And play music again. Okay, right. I check your code when stop the music. Did you turn on, turn off? This why LED on and off? The same code. Okay, very good. I saw the Arduino board layouts. Please move the slide to the Arduino layouts. Here, what is the Arduino block and the diagram? What is it? Yes. Like, what is it? Not mentioned. Okay. We will take a pictures. Okay, so could please open the first line? A photo. Okay, one, สักครู่นะโทรศัพท์ 1, 2, 3. Okay, thank you. The next presenter is Jilapat. Jilapat.
Hello. Thank you.
One more time.
Again, please.
Our objective is creating an Arduino LED dancing project aimed to foster learning and skill development in Arduino programming, electronics, and basic circuitry. The project emphasizes creativity and aesthetic in designing and controlling LED light patterns. Additionally, it incorporates sensors to create a responsive LED experience based on external stimuli
The project focused on problem-solving skills, documentation, and presentation, aiming to create an engaging project, both technically and visually. The ultimate goal is to produce an interesting project that combines technical proficiency with visual appeal. The next one is motivation. The motivation for creating an Arduino LED dancing project is driven by a curiosity to explore and learn in the fields of electronics and programming. This project serves as a hands-on platform to enhance programming skills, delve into circuitry, and express creativity through visually appearing LED patterns. The challenge of problem solving coupled with the opportunity to document and share the project as a satisfying dimension to personal growth and skill development. Ultimately, the project is motivated by a blend of curiosity, the joy of learning, and the fulfillment of bringing a creative vision to fruition.
About a component of we use Arduino Uno reform LEDs, resistors, and wires. For coding, we use the same as teacher teach, but we adjust a little bit. We adjust what LED to light up and what millisecond to things we can use it.
Okay.
Okay, this is our problem. When we're working on an Arduino LED dancing project, we have some problem include cannot find the location of file. We need to do coding again, and LED is always broke. Thank you.
This is always broke. This is mean LED is so very brightness. Could you explain very broke? This is always broke. This is a very LED is a brightness. You mean brightness when you record the video is very brightness, right? Okay. And because this is you use the super bright LED maybe. And please play the video, okay? TikTok. I love you video. Okay, and show you the live score on TikTok. How many score? This is a play video and right in the TikTok. The TikTok score. You upload on the IT?
Yes.
IT? Oh. ตรงไหนอ๋อ 300 so well okay very good I think your content is the main focus for the video. This is the dancers, not the LED. Okay, thank you. Before we take pictures, photos, open the first slide. Okay, 1, 2, 3. Okay, come. The next presenter is Thirasit.
Hello.
Okay, hi, ladies and gentlemen. So now we're gonna present about 5 LED dancing with music project. First, I'm gonna talk about project description. Our task is to make 5 LED lights react with music by implementing code for the lighting pattern. The song we have selected is God of Music by 17. And this is our table of content. We have objective. The objective is the main is of the project to gain a comprehensive understanding of breadboard and Arduino fundamentals by designing and implementing a simple LED circuit on a breadboard. We writing code for various lighting patterns using Arduino. This involves learning about breadboard usage, Arduino programming basic circuit design, principle and LED pattern programming. Through experimentation, automation, and documentation, the project aims to further practical skill in circuit construction, code development, debugging, and reflective learning. Additionally, knowledge transfer to sharing excellence and insight contributes to the broader Arduino community, enhancing collaborative learning opportunity, make it bit longer.
So here's our material description. First, we have LED red, 2 LED green, 1 LED blue, 5 of resistor 220 ohm, 1 breadboard, 6 wiring cables, Arduino Uno board, and USB cable. For the implementation stage, first step, create a breadboard for LED circuit. For this step, we need to build the circuit for the LED lights. We start by placing 5 LED lights into the desired pattern. Then we use 220 ohm resistors for each LED light. Next, we use jumper wires to connect the LEDs from the breadboard to the Arduino Uno. For next step, connect Arduino to computer. After we have finished setting up the circuit board, we then connect the board to the computer. We use the Arduino IDE to establish this connection. Next, we select the board to work with. Third step, choose the music and create the pattern. At this step, we choose the music we want to work with. Once we have the music, we begin planning out LED pattern. Fourth step, write the code for the pattern. Once everything is set up, we can continue to write the code. For this project, we use the C language to write the pattern for the LED. And last step, adjust the code and testing. The next step is to test if the code or pattern is correct. If the LED pattern does not fit with the music, we then use this step to adjust it until we achieve the final result that we are happy with. And this is how our work looks like.
And this is Arduino code. So we firstly start with this file for define pin number for LED and then switch. And for the on and off, we define it as high and low, which is Arduino programming setting pin stage. And then we have Steam message, and this is an array where we can store up to 10 messages. And then for the voice setup, this is when we define each LED as an output, and then we define switch as an input. And for the LED on and off function, this is when we define each individual LED to turn on and off based on the input. And for the delay time parameter is used to put the delay so it can make up with our pattern. And next we have while loop. So I'm creating this loop so I can creating my pattern and then put it to the loop to make it execute. And this is example for the pattern blink 1. So this is how I'm creating each pattern here. So I have blink 2, and then for the each blink I have like is explanation for the music I use, and then for the blink so this is where we have later pattern for the blink or LED. And here is our pattern. So we put numbers so you can see how it go in order. So we start like Chuncho, Nole, and then from here we make it spread out the LED light from the center to both sides. And then for Chigumne, Gunne, this one we go in pattern. And for Jirene, this one we start for the leftmost and continue to bring all the way to the right, same with the name. And this one is hook. So as you can see in Kumti Pakti, this one I use two LED to blink together in a pattern like Kumti Pakti. And for Kum is same as I mentioned before. It's gonna start splitting out from the center 2 times. And then for Paktian, this one is we going in order again. And this is the last pattern of our project. So Hanbok Kum Haro, this one we start in order, and for Zigum is as I mentioned, start from the leftmost, and this Kum start from the rightmost. And for Mia, I mean this one I put all because all the light for LED light is blinking together.
The problem we have faced while testing the project, we noticed that the LED pattern linked with the Arduino Uno didn't always match the rhythm of the chosen music. Upon the closer look, we realized that the timing and transition between LED chain didn't always line up with the music beats. This caused some moment where the visual effect seemed out of sync with the music. However, after the tweaking, the code by adjusting how long the LEDs stay on and making sure they stay at the right moment in the music. Without being implemented, this made the whole experience more cohesive and enjoyable. These findings show how important it is to fine-tune the LED pattern or to match the music better, making the project more impactful overall. Observation: the LED circuit board is powered by connecting it to the computer via a USB cable, which is then plugged into the Arduino Uno, ensuring everything runs smoothly. The code writing in the Arduino IDE is in C language, making it easy to understand and modify to fit specific project needs. LED patterns are controlled by the built-in code onto Arduino Unos, providing consistent and dependable management. Users can easily adjust timing and duration within the Arduino IDE, allowing LED transition to sync up with the music tempo and rhythm. The program effectively adjusts LED patterns based on user preference, highlighting the importance of defining the code to improve performance and synchronization for better project outcome.
Okay, so I'm gonna continue with the conclusion. Our project was all about getting to know Circuits and Arduino better. We got hands-on experience by building a basic LED circuit and writing code for different light patterns. And this helped us understand how circuits and Arduino work. Also, we faced challenges like making sure the LED lights match the music. We keep going and learn a lot. Looking ahead, what we learned from this project will help us reform the project and report more personal with Arduino.
Maybe you can extend this program for the senior projects by add or include the microphones to capture the music from the bass based on the music and make a setting the delay time. Maybe you can improve it to the senior project. This is a
Thank
suggestion.
you.
For take the photo, please. 1, 2, 3.